Hi everybody, today we're going to talk about imaginary numbers. But before we do that, we just have to talk about normal numbers. So when we look at number 1, we're just adding like terms. So negative 1 plus 3 is 2, and 2x plus 5x is 7x. And that will be it. Letter B, we need to distribute this negative sign. That is one thing a lot of people forget to do, and it messes them up. And now we combine like terms. So 1 minus 4 is negative 3. And negative 3x minus 3x is minus 6x. Then we have a distributing problem. So when we have this 3, it's going to distribute to everything on the right side. And then x will distribute everything on the right side. So we're going to have 15 minus 12x plus 5x minus 4x squared. We see like terms. So we're going to combine those together. And we will get negative 7x. And if we just want to write it in proper notation, we'll just flip it around to have the highest powers in the front. All right, so this instructions I forgot to mention, says simplify. So it's not that you're solving for anything, you're just writing it in a more simple way. All right, next set of instructions say solve. So here solving means we're going to get x by itself. Since I have a square, I'm going to take the square root on both sides. And when we take the square root, it's plus or minus 3. And you're done with that problem. For letter B, you want it to be pretty similar to A. But in order to do that, we need to get rid of the negative 4 and the 3. So we're going to add 4 first. And then we're going to divide by 3. And then look at that, plus or minus 3, because we pretty much get the same problem that we had earlier. C is going to be the same thing, but this time we have fractions. So I'm going to go ahead and subtract 2. And now I'm multiplying by 1/3. So how do we get rid of 1/3? Multiply by 3. X squared equals 9. And x equals plus or minus 3 once again. And now I have this last problem, which is interesting, which is x squared equals negative 9. So one thing to keep in mind is we can just think about this problem. Anytime you square something, you always get a positive number. So the fact that it's x squared equals negative 9 is kind of suspicious, but let's proceed like normal. So x equals plus or minus square root of negative 9. But once again, what same two numbers multiply to give you negative 9? Nothing exists. Nothing exists. So this is when mathematicians kind of make something up. So I'm going to tell you the story. I know it's a little strange, but one thing that we need to realize in math, the idea of having 0 or a negative number was really crazy to people. So if you think about natural numbers, which is 1, 2, 3, 4, and 5, it was really hard to convince somebody that 0 was a number as well. So how can 0 be a number? Like, that's nothing. How can negative 2 be a number? How can you have negative 2 cows, for instance? But mathematicians had to make symbols and ideas in order to represent things that we couldn't quite understand. So the idea of 0 represented just nothing. So negative 3 plus 3, well, if I'm down 3 and I add 3, I have 0. We got this idea of 0. And then negative numbers could represent debt. Well, I had $2 and I owe $5, so that means I'm down $3, which is negative 3. So mathematicians did something similar with square roots of negative numbers. We all know that the square root of negative 9, there's not two same numbers that exist to give you negative 9. So what mathematicians did is they decided, and you should write this in your notes, that the square root of negative 1 will be I, and this I will represent imaginary numbers. So for this problem, we're going to write x equals plus or minus negative 1 times 9. and x equals plus or minus negative 1 times the square root of 9, x equals plus or minus I, and then the square root of 9 is 3. So we'll just write it a little better because it looks pretty weird to say I3. So we're going to say plus or minus 3I. So anytime we have a negative square root, we can represent that with an I. And that's what happened here. Okay? So it's really weird, but this right here is a really important idea. All right? So I'll kind of show you like what this looks like on a number line. So I'm just going to erase all this for a second and kind of show you what this number line, another way to think about it. So mathematicians decided to think about this on a number line. So I know you're used to x and y, but instead of x and y, we're going to think of this as being real and the y-axis as being imaginary. So I just told you that the square root of negative 1 equals I. So what about if we squared both sides? So that means that I squared equals negative 1. So what we're going to do is we're going to kind of make a little circle. So here, I'm going to say I to the power of 0, which equals 1. We all know that in math, anything to the power of 0 is 1. So it would make sense for I, even though it's imaginary and weird, I to the power of 0 to equal 1. So then I'm going to come over here and write I to the power of 1. Kind of think about it as like a circle. Well, I to the power of 1 is just I. So that kind of makes sense because what I'm saying here is that the y-axis will represent imaginary numbers. Then I come here and I have I squared. Well, we just proved that I squared is negative 1. And once again, do we see that I squared is a real number, which is negative 1. Then we get here and we have I cubed. So what is I cubed? Well, we can write I cubed as I squared times I. We know that I squared is negative 1. So negative 1 times I is just negative I. So I cubed, and I'm going to highlight that, I cubed equals negative I. So let's just do this cycle one more time. Now I get to I to the 4th. Well, I to the 4th is I squared times I squared, which is negative 1 times negative 1, which is 1. So I to the 0 and I to the 4th gives me the same answer as 1 because we're making this periodic circle. I to the 5th, well, that's I squared times I, which is negative 1 times negative 1 times I, which is I. So I to the 1st and I to the 5th have the same value of I. And I can just keep doing this over and over again. Now I have I to the 6th. A shorter way to write this would be I squared to the power of 3, which is negative 1 to the power of 3, which is negative 1, which is the same thing as I to the 2nd. And then finally, I to the 7th. I think an easier way to write this is I squared to the 3rd times I. So that's going to be negative 1 cubed times I, which is negative I, which is the same thing as I to the 3rd. And just to do it one more time, let's do I to the 8th, which is I squared to the 4th, which is negative 1 to the 4th, which is 1. So as you can see, it goes in a circle and the values repeat over and over again. So what we're going to do with this plane, we're not really going to get into it right now, but it just kind of helps you think about this real axis and imaginary axis. All right, so I'm going to erase this, and I'm not going to go over all these problems because I actually did some of them for you, so I'll kind of help you with the harder ones. So if you just go back and rewind the video, I did pretty much all of these already for you. So then the question is, how do you do I to the 27th? So my rule of thumb is when it's odd, always make it even. So if it's I to the 27th, I would do I to the 26th times I. Because I know I can write I to the 26th as I squared to the power of 13 times I. And I to the second is -1. And if I multiply -1 an odd amount of times, that means I'm going to get -1 times I, which is -I. So I to the 27th equals -I. All right? A little weird, but hopefully it kind of makes sense. Just to give you one more example, if I said I to the 100th, I would do I to the second times 50, which is -1 to the 50th power. And if I multiply -1 by even amount, then I know my answer has to be 1. That's just another example. All right. So next, we have the operations, which we did on the top, but this time instead of x, we have I. So -1 plus 3, that's 2, everybody. 2i plus 5i, 7i. We are done. Pretty much treating I like x. Letter B, distribute. 1 minus 3i minus 4 minus 3i. 1 minus 4, -3. -3i minus 3i, -6i. We're done. Last one, we're going to distribute. So we're going to distribute this. And there's going to be a little twist to this, which I'll show you. So it'll be 15 minus 12i plus 5i minus 4i squared. 15 minus 7i minus 4i squared, which is what we did earlier. But there's one thing that you have to do to simplify this. So does everybody notice -4i squared? Well, I squared from earlier equals -1. So you're going to do 15 minus 7i minus 4 times -1. So this would be 15 minus 7i plus 4, which will give me 19 minus 7i. So we were able to use I squared to simplify something that looked different. So let's write down our notes to conclude this. So first thing that we need to know is the square root of -1 equals I. And an example of that is the square root of -16. There is not two same numbers that multiply to give you -16. So we will have to do -1 times 16, which is -1 times square root of 16, which gives us 4i. So that was one example. Another thing that we learned about was I squared equals -1. This is just really important to know. You'll see this on the ACT, and you'll see this in a lot of problems that you work with. And last thing that we haven't really talked about is anytime you get something imaginary, it's called a complex number. And complex numbers look like a plus bi. This is a real number. And this is the imaginary part. So you might have saw above, like when we saw -3 minus 6i, this is the real part, and this is the imaginary part. All right. So one thing we also need to know about complex numbers, and it won't really make, I guess it should make sense because when we dealt with square roots, so for instance, like x squared equals -12, x equals plus or minus square root of -12. So x equals plus or minus I root 12, which I can simplify. But the one thing that you need to know is all imaginary / complex numbers come in pairs. So for instance, if you were solving a quadratic and you got something like 3 plus 5i, then you're also going to see 3 minus 5i. This will make more sense when you start doing the quadratic formula, which we'll do next lesson. But just kind of write in your notes that imaginary numbers come in pair, and we call these conjugates, which you might have heard when we did trig. All right. These problems at the end, I will post an answer key for these, but I kind of want you to try these on your own based on what we talked about. Thank you for watching, and see you next time.